Hello and welcome to the 3-5 Notes. This is a section about proving lines are parallel. And I kind of just want to jump in here real quick and do this first part. And it states that, or it asks, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So what I want to do is take a look at this, and it asks which lines would have to be parallel in order to show that angle 3 and angle 7 are congruent. So I'm going to come over to my picture, and we want to show that angles 3 and 7 are congruent, okay? And so what we would have to do is we would have to state that these would have to be alternate interior angles to show that A and B are parallel around this transversal L, okay? So let me come over here, and we would have to say that lines A would have to be parallel to B, and these are alternate interior angles, okay? And so then, let's take a look at angles 9 and 11, okay? 9 would have to be congruent to 11. Okay, here's 9, here's angle 11. These are corresponding angles. So A and B would have to be parallel in order for these two angles to be congruent. So I'm going to come in here and I'm going to say A would have to be parallel to B, and these are corresponding angles, okay, for us to say that. All right, let's take a look at question 3. 2 is congruent to 16, so here's angle 2, here's angle 16, and so this is your transversal. These two lines, L and M, would have to be parallel to show that 2 is congruent to 16. And those angles are alternate exterior angles. So I would come in here and I would say that line L is parallel to line M, okay, and those are alternate exterior angles, okay? So then let's take a look at question 4. It says that angle 5 plus angle 12 is equal to 180. So here's 5 and here's 12. These are same side interior angles, okay, around transversal B. So that means that L and M would have to be parallel. So I'm going to say that L is parallel to M, and these are same side interior angles, okay? So you're just kind of looking at those and just verifying that, you know, if these statements are made that these are congruent, we have to figure out what lines would be parallel, okay? Let's take a look at number 5, okay, and it says find x so that line L and M are parallel to each other. Okay, so if lines L, if lines L and M are parallel and they're cut by a transversal K, then these two angles would have to be supplementary. Okay, so I'm going to find x that would make that true. And so I would set up the equation 2x plus 6 plus 130 is equal to 180. Okay, and so then I get 2x plus, okay, 6 plus 130 is 136, and that's equal to 180. Okay, and then I would subtract 136 from both sides, and we would get that 2x is equal to 44, okay? And if we divide both sides by 2 and by 2, we get that x is equal to 22. So what we're trying to say here is that if x is equal to 22, okay, that makes this equation here true, okay, and then that would make that these two lines are parallel. Okay, so now let's take a look at number 6. Number 6, these angles are alternate interior angles. Okay, if line L and M are parallel cut by transversal K, then these two angles here are congruent. So if they're congruent, then I would set 3x plus 10 is equal to 4x minus 10, okay? And I would go ahead and add 10 to both sides, and I would get 3x plus 20 is equal to 4x, and then I'd subtract 3x from both sides, and we would get that 20 is equal to x, okay? So if x is 20, then it makes these two angles here congruent, and so lines L and M would have to be parallel cut by transversal K. So let me put in there, and let me draw in here that these are parallel if x is 20, okay? All right, let's take a look at number 7, okay? If lines L and M are parallel cut by transversal K, then these two angles are alternate interior angles, and those angles are congruent. So let's find x that would make that true. And so I would set 6x plus 4 is equal to 8x minus 8. All right, and so I would add 8 to both sides, and we would get 6x plus 12 is equal to 8x. And then I'd subtract 6x from both sides, and we would end up getting that 12 is equal to 2x. And so divide by 2, and so x is equal to 6. Okay, so that is the value for x that would make these two values, these two angle measures congruent, which would then, since those are alternate interior angles, would make L and M parallel. Okay, so I'm going to draw in those little symbols to show that those are parallel. Okay, let's take a look at the next question, and it's asking us to do a proof. Okay, so the first thing I want to do is draw my my table here, and I want to put statements and then reasons. Okay, and the first thing that we're going to do is we're going to write down the given information. Okay, and so my first statement here, 1, is that angle 1 and angle 2 are complementary. Okay, you guys are all doing a great job. Complementary. Okay, and that's given to you. Okay, Merry Christmas, Happy Hanukkah, Happy birthday. And then the second statement that I'm going to write down is that BC is perpendicular to CD, okay? And that's also given, okay? And so what I know, let's go ahead and write in some statements here, draw some pictures. The first thing I know is that BC is perpendicular to CD. So if these are perpendicular, okay, then I know that I can draw a right angle there, okay? And so if I know that, and I'm just trying to draw a conclusion from this statement here, if those are perpendicular, then I know that that angle BCD, okay, is equal to 90 degrees, okay? And the reason I know that is because we're given that these two segments are perpendicular, okay? And if they're perpendicular, then they make a 90-degree angle. So my reason for that, the reason that I can say they're 90, is that that's the definition of perpendicular lines, okay? They form and make a 90-degree angle, okay? Now, the other thing that I can conclude from here is that angle 1 and angle 2 are complementary. So what that means, the fourth statement that I can write is that angle 1 plus angle 2, that's equal to 90 degrees, okay? And so let's go up here and let's draw that also in the picture, okay, that those are 90 degrees, all right? And so the reason that I can say that in part 4 is that that's the definition of complementary angles. Okay. Okay, and so the conclusion that I can draw from part 4 is that so my statement in part 5, what I can conclude from this statement here that they add up to 90 degrees, I can then say that angle ABC, okay, is equal to 90 degrees. Okay, and that is the definition of complementary angles. Okay, and so we have to think about what we're trying to prove here, okay? And what we're trying to prove is that line BA is parallel to line CD. Okay, we're trying to prove that these two lines are parallel. Now, what I'm going to do real quick is I'm going to extend this line out just a little bit here and here, and I'm going to extend out line BC here and here. And so what I have created here is I've created two lines cut by a transversal, okay? And so if these two lines are parallel, then B angle, ABC added up to angle BCD would have to equal 90 degrees, or have to equal 180 degrees, because these are same side interior angles. So because I know that these angles are both 90, okay, I'm going to add them together. Okay, and the reason I'm going to add them together in step 6 is that I want to show that they add up to 180. So I'm going to say that angle BCD plus angle ABC is equal to 180 degrees. Okay, and the reason I can add those two angles up is the angle addition postulate. Okay, and then what I can do is I can substitute a value of 90 in for each of those. Okay, so angle BCD, that's 90 degrees, so I'm going to write 90 degrees plus angle ABC, which is also 90 degrees. Okay, and I'm going to add those up to equal 180. Okay, and all I did there was I just substituted my values in. So substitution. Okay, and then, we know that this statement is true. Okay, so then I know in step 8 that I can say that angle BCD and angle ABC, okay, I can say that those angles are same side interior. Are same side interior. Okay, and so that's the definition of same side interior. Okay, and then in part 9, okay, I can say if those are same side interior and they add up to 180 degrees, then I can say my proof statement that BA is parallel to CD. Okay, is that what it was? Yeah, BA is parallel to CD. And so the reason that I can say that is kind of a specific theorem, but what I'm just going to say here is that that's the that you just had same side interior angles. Okay, there are a number of theorems that we can use, but for our purposes, guys, I want you to just be able to go through the logic, okay, of these proofs. Okay, I'm more interested in you making the statement that, okay, these both have to be 90 degrees, these two angles. If I add them together, I get 180. If they add to 180, then they're same side interior, and if they're same side interior angles that add up to 180, then these two lines have to be parallel. So I know it's kind of confusing to you. We'll work on a bunch of problems in class, but I hope you enjoyed this video, and we'll see you soon. Thanks. Bye.